we are going to complete a small activity at the bottom of this page, but in order to do so, we're going to have to go over some vocabulary. All right, so in order to complete this, we got to go over a couple of vocab terms. You guys already know what these words mean. We're just going to talk about it in reference to a figure like this. Okay, so we all know that in a right triangle, the side that is across from your 90-degree angle in this figure, that would be this side right here, AB, is called the hypotenuse. We all know that. Across from the 90 is our hypotenuse. Okay? All right, the two terms that we want to go over are opposite and adjacent. Okay? So it says that if you are asked to find the side opposite of angle A, okay? So in this figure, here is angle A. I am looking for the side opposite from that angle, or the side across from it. In this case, that would be the side BC over there. Okay? All right? Then they want to know what would be adjacent to angle A. So back on our semester review just a couple weeks ago, we talked about what adjacent meant. It meant that it shared a side, right, or it's right next to. So for angle A, these are the two sides that make up that angle, right? So it's got to be one of those two. Well, we already said this one was the hypotenuse, so it's got to be the side AC there on the bottom. Okay? Now, the adjacent and opposite side can change depending on which angle they are asking you to look at. So these were the opposite and the adjacent when I'm looking at angle A. Okay? So that's what it's saying here. If they are asking you to look at angle B in the exact same figure, the side opposite is now side AC. The side adjacent is now side BC. The hypotenuse will stay the same, right? Because it's always one across the line. But your adjacent and your opposite can change depending on what angle they're asking you to look at. Okay. All right. So remembering that opposite means the one that's directly across from the angle, and the adjacent is going to be the one right beside it that's not the hypotenuse. I want you to fill in these blanks. So on these first two figures, you are telling me which side is opposite, which side is hypotenuse, which side is adjacent. In these two figures, they're telling you the sides. You tell me, are they opposite or are they adjacent? Okay? I want you to do that with the people in your row. If you're in a row by yourself, turn around either forward or backward and join the group with behind or in front of you. Okay? I'll give you a couple minutes to do that. Okay. In figure 1, which side is opposite of angle M? Good. Also, remember, whenever we name a side, guys, we put that line above the two letters, okay? All right, which side is the hypotenuse? Good. Okay. And what's adjacent to angle N? Also empty. Good. Okay. All right, in figure 2, which side is opposite of angle Q? Good. And which side is adjacent to angle Q?
QR.
QR, very good. And what's the hypotenuse? Good. Okay. All right, on these next ones, you guys are telling me, are they opposite or adjacent? So we're looking at side YZ. Okay. Is it opposite or adjacent to angle Z? Adjacent. Good. Okay. All right. Side XY is what to angle X? Also adjacent. Good. Okay. A good way to tell is if the line touches the angle, it's got to be either adjacent or hypotenuse, right? Okay, and we know for sure which one's the hypotenuse. All right. On number 4, side CB to angle A.
Opposite.
Good. All right, inside CG in relation to angle B. Good. Okay, so does anybody have any questions about how we can identify which ones are opposite, which ones are adjacent? We're good there? Okay, if you will flip it over onto the next page. Okay, so on this section here, with your same group that you were just working with, you guys are going to take your rulers and measure the side lengths of both of these triangles and write them over here on the blanks. Make sure you are measuring in centimeters, okay? We want to be as accurate as possible. So, remember each line is like a decimal point because there are 10 lines. So, 2.3, 1.9, stuff like that, okay? All right, I'll give you a minute to do that. Go ahead. All right, so we are trying to be as accurate as we can. I already heard some of you guys like debating with your partner what exactly it is. So as long as you're within a decimal point or two of each group, then we should still be okay. All right. So what did most of us get for PQ? 3. Okay. All right. What about side QR?
2.
Okay, 2, I heard a couple 1.9s last period, so it's one of the two, right, somewhere in there. They're only within one decimal point of each other. 1.9 or 2, either one would be okay for what we're looking at. All right, what about PR?
2.3.
2.3, 2.4, is that what you were going to say? Yeah, 2.3 or 2.4, either one should work, okay? So you can write either one. Okay. All right. What about side DE?
6.7.
6.7. Okay. What about EF?
4.4.
Okay. Again, within a decimal point or two, either direction, and then EF.
5.2. 5.2.
Okay. Okay. All right. So, whenever we get down here, they are asking us to only be looking at the measurements for triangle PQR. So we only need these 3 numbers right now. They want us to fill in the sides that are opposite and adjacent and then actually plug in those numbers and find out what the simplified ratio would be. Okay? So, in this figure, we're looking at the 40-degree angle. Okay? Which side is opposite of the 40-degree angle? QR. Okay, so that's what I'm going to put right here. QR. All right, which side is the hypotenuse in this figure? All right. Okay. All right, and then for the side lengths, we said that QR was 1.9 or 2, whichever you guys wrote down. Okay, over side PQ, which we said was about 3. Okay. Okay. So we're going to use our calculator to divide those and turn them into a decimal. So 1.9 divided by 3, or some of you put 2 divided by 3. What do we get approximately?
0.663.
Okay, 63. If you divided 2 by 3, you got a little bit higher than that, right? Something along those lines, though? Okay, so I would say a happy medium between what we got would be around 0.64, depending on if you used 2 or 1.9. Okay. All right. Okay, so for the side adjacent to 40, what side is adjacent to 40? PR. And you guys already told me that the hypotenuse was PQ. Okay. So we said that side PR was about 2.3 or 2.4. Okay. Divided by, again, our hypotenuse, which we said was 3. So what do we get when we divide those numbers?
6.766.
Okay, 7, 7, 7, 6, I'm hearing, so somewhere along those lines. Okay. It also depends on if you're using the exact degree or if you went up or down, right? So we'll say it's somewhere along those lines. Guys. Alright, and then we've got the side that is opposite, okay, which we said was QR, over the adjacent, which we said was PR. So for us, opposite we said was around 1.9 or 2. PR we said was about 2.4. And what do we get when we divide those? 0.82, is that what you said? Okay. Okay. It should be somewhere within a decimal place or two of this, depending on what number. Okay. Again, these can fluctuate 1 or 2 decimal places depending on your numbers, right? Okay. All right, now we're going to do the exact same thing, but looking at triangle DEF. So, in triangle DEF, which side is opposite of the 40? Okay. And which side is the hypotenuse? DE. Good. Okay. If we go back up here, we said EF was 4.4 and DE was 6.7. So we'd have about 4.4 over 6.7. Okay. When I divide those, approximately what do we get? 0.66. Okay. Again, if you use bigger or smaller numbers, that can fluctuate a little, right? Okay. All right, then we have adjacent. What side is adjacent? DF over, again, the hypotenuse, which was DE. Okay, so if we scroll back up here, we said that DF was about 5.2 over that same 6.7. What do we get approximately when we divide? 0.78. Okay. All right. And then lastly, we've got opposite, which we said was EF, over adjacent, which we said was... Okay, so our numbers for EF were 4.4, and for DE, we said it was about 5.2. And what do we get when we divide those? 0.85. Again, could change depending on your numbers, right? Whatever I measured, I got closer to 0.84 or 83. Okay, something along those lines. Okay. All right, so whenever we flip it over onto the next page, they ask, are the ratios for triangle PQR column pretty close to what we got for our ratios in DEF? Yeah, they're very close, right? Obviously, there was room for error in measurement, okay? So, we do say that they are pretty close. What would that mean about these two triangles? They are similar triangles. So, because the triangles are similar, the ratios were the same, or at least very close to the same. And remember, similar just means that they're the same shape, not necessarily the same size, right? One's bigger or smaller by some ratio or scale factor. Okay. All right. Then they want us to determine the values of sine, cosine, and tangent of 40 in our calculator. Before you try and solve it in your calculator, you have to make sure that your calculator is in degree mode. Okay, so anytime we're doing these problems, make sure you go in and check before you start solving, because it will give you the wrong answer if it's in radian. Okay, so in order to do so, the blue button that says second, right beside it, there's a button that says mode. You click mode, and the fourth one down says radian and degree. You guys see that? Everybody see where it says radian or degree? Go over to where it says degree and press enter. Make sure that degree is highlighted in black. Okay? That will make sure that it's saved as long as you're on it. Now if somebody goes in and resets it, it'll go back. So make sure you always come here and check that it's in degree mode. Okay? I think that first period probably already set it in degree mode for you, so most of you probably didn't have to. Alright, so after you have degree highlighted, you got it? Anybody need help with that? Mode, degree. Fourth one down.
It's in Spanish. German. That's German.
Okay, well I don't know how to change the language. She may have to
It's
reset.
in German.
Okay,
It's all the way at the bottom.
so after you have chosen the correct mode, close out of that. You can just press second mode. It'll go back to your home screen. And we're going to find sine, cosine, and tangent of 40 degrees. So in order to do that, you're going to press the button that says SIN. Everybody see that on your calculator? Press that button and it should open a set of parentheses. You're going to type 40 in the parenthesis, close the parenthesis, press enter. What do you get? 0.64. Okay? Do the same thing for cosine. Press the button that says COS, type in 40, close your parenthesis, press enter. What do you get? 0.77. Okay? Alright, same thing for tangent. Tangent of 40 is approximately 0.84. Okay, was everybody able to type theirs in the calculator and get these decimals? Yes. Okay. Alright, so these decimals, how do those compare to the decimals that we just filled in for our other triangles? Are they pretty close? Yes. Okay. Alright, so that's what we're going to say here. These decimals are very close. And then they tell us why that is. It says it is a mathematical fact, so it has been proven that anytime you have a right triangle and it has an angle of 40 degrees, if you take the measure of the opposite side and divide it by the hypotenuse, then you're going to get 0.64 about. Okay? That is what we call sine of 40 degrees. Okay? Anytime you've got a right triangle with a 40-degree angle and you have the adjacent side being divided by the hypotenuse, then you're going to get about 0.77, and we call this cosine of 40 degrees. Similarly, for a triangle that has that 40-degree measure, if you take the opposite side and divide it by the adjacent side, you're going to get approximately 0.84, which is tangent of 40 degrees. Okay? All right. This obviously can change if you're not looking at a 40-degree angle. Right? That would change your numbers. Okay? But these ratios will stay the same. If they ask you to find sine, they will ask you to find sine for some particular angle. Okay? In a problem where they don't give you the angle, 9 times out of 10, they're going to call that angle theta. Theta is just a Greek letter. It's just a variable. Okay? But I do want you to see how it would be written. So it would be sine of theta. It's like a long oval with a little line in the middle of it. Is what it looks like. Okay? And we said that to find sine, you're going to divide the opposite side by its hypotenuse. Right? So that's what I'm going to write here. Sine is opposite over hypotenuse. Okay? Same idea for cosine. They will probably ask you to find cosine of either a specific angle or cosine of theta. And we said to find cosine, you're going to divide what by what? Adjacent by the, there you go. Alright, and then lastly, our tangent, or tangent of theta. How are we going to find that? Okay. Alright. Now, like I said, depending on what they say theta is, that could change what answer you get, but it's going to be up to you to know. If they tell you to find sine, that you know it's opposite over hypotenuse. Or if they ask you to find tangent, you have to know to use opposite over adjacent. And yes, order does matter, right? Adjacent divided by hypotenuse, you can't just flip it over, right? 6 divided by 2, not the same as 2 divided by 6, right? You cannot flip them over. So, in order to remember, they have a little, what do you call it with like the words stand acronym? Is it an acronym?
Yeah.
So they have a little acronym for you. It's called SOHCAHTOA. Okay? So SOH. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. And it's a really weird word that you don't tend to forget, so I think it works. Okay? That